Hi, we're going to discuss properties of limits today. So we're going to start by assuming that we have two functions, f of x and g of x. So the limit as x approaches c, the limit of f of x is going to equal some number k. The limit of g of x as x approaches c, the same value, is going to be L. KL and we're also going to use some number P are all real numbers. That's what this notation here means. And we want L to be positive just to make some of the things easier to deal with. Okay? So what are the properties? If you're trying to add the limit of one function, another function, or subtract the limit of a sum or a difference, you can write that as the limit of f of x plus or minus the limit of g of x, which is going to equal. So the limit of a sum is the sum of limits. The limit of a product is the product of limits. The limit of a product of some number times the function is going to be that number times the limit of the function. The limit of a quotient of two functions is going to be the quotient of limits, and as I mentioned earlier, L is positive, so we're not going to have any issue with dividing by 0. Remember, here L cannot equal 0. Okay, and then you have the limit of a function raised to a power is going to be the limit of that function raised to the power, and then the limit of a root, nth root of a function is going to be the nth root of the limit of the function. So they're very simple, and we're going to do some problems now to take a look how this works. Right? So what we have here is we have two functions, f of x and g of x. So we know that the limit of f of x as x approaches some c is 4, and the limit of g of x when x approaches the same value is -7. So here we're trying to do the limit of this expression, so it's going to be the limit as x approaches c of f of x plus the limit as x approaches c of g of x, which is going to be 4 plus -7, and that's -3. Product. So we have the limit as x approaches c of f of x times the limit as x approaches c of g of x, which is 4 times -7, and that's -28. So here we have this. I'm not really going to write that whole thing out. A, I don't have a lot of room, and B, it's actually a lot easier than sometimes people think. So we know that's going to be the limit of this expression, so basically I can figure out my individual limits here. Well, let me write this one out a little bit. So it's going to be the limit as x approaches c of 2f of x minus the limit as x approaches c of g of x. So these two here, you can move this 2 outside because it doesn't really have any bearing on the answer as far as, well, the limit itself. So it's 2 times 4 minus -7. It's going to be 15. So you can actually, if it's as easy as this, you can just substitute those values in here. So when we try to do this limit, it's going to be the limit of the square root of f of x plus 3 times the limit of g of x as x approaches c. So it's going to be the square root of 4 plus 3 times -7. So it's 2 minus 21, which is going to be -19. The limit of a quotient. So the only thing that we need to care about is that the denominator's limit is not 0. It's not. So it's going to be 4 divided by -7, which is -4/7. And the limit of g of x to the third power as x approaches c. So it's going to be, oops, my apologies. It's going to be the limit as x approaches c of g of x, the whole thing raised to the third power, so it's negative 7 to the third power, right? Which is going to be 343, right? 343. Okay, so what I want to show you next is what happens when you deal with graphs. It can get a little tricky. This is usually something pretty simple. So we have these two graphs. So the graph on the left is the graph of f of x, the graph on the right is the graph of g of x. As you can see, functions have some breaks, holes, but you know, we're dealing with limits, so it's not really that important. Well, may or may not be, we'll see. So we're trying to do the limit as x approaches 0 of f of x plus g of x. So first of all, you need to make sure each individual limit is defined. So the graph of g of x is right there. The limit at 0 is going to be 2. Right there. So this limit is 2. What's the limit of g of x as x approaches 0? 0 is here. The function has no breaks. The limit is 1. So it's 2 plus 1, which is 3. The limit of the product of f of x and g of x as x approaches 2. As x approaches 2, f of x has a limit, it's 1. And g of x, as x approaches 2, there is a hole, but there is still limit here, because on the right, on the left and on the right, the graph is heading towards the same value, so it's actually 3. So it's 1 times 3, which is 3. The limit of the quotient of g of x over f of x as x approaches negative 1. Let's see if each one of them exists. So the g of x as x approaches negative 1, the limit here is 0. The limit of f of x as x approaches negative 1 is 1. So it is 0 divided by 1, which is 0. Okay. 3 more questions. So now we're dealing with one-sided limits. As x approaches 1 from the left of f minus g. So as you approach 1 from the left, f of x is going to approach negative 1. Right? You're approaching this graph from this side, it's heading towards negative 1. G of x, as x approaches 1, is going to, from the left, is going to approach 2. So it's going to be negative 1 minus 2, that's negative 3. Same expression, f of x minus g of x, but we're approaching 1 from the right. So when you approach 1 from the right, f of x is going to approach 0, right? And g of x is still going to approach 2. So 0 minus 2, which is negative 2. So what is the limit of f of x minus g of x as x approaches 1? Well, it does not exist, because we want to remember from conditions of having a limit, one-sided limits must equal each other, and these two numbers are not equal to each other. Negative 3 does not equal negative 2, hence the limit at the point does not exist. Okay, so I hope this helps.